Welcome to Let's Make a Game Platformer, episode 14. In last two episodes, I have added a splash screen to the game that is running off of a prefab here, splash series, specifying which images and for how long and what background should be displayed. And also in last episode, I've done some refactoring for having the game loop being done using events rather than registering listeners. So in this, I'll start this episode with doing a little bit of cleaning up here. So I'll create a gameplay package here. Oh, it's already here. And instead, so it's going to be a menu and gameplay. So we'll move everything into the gameplay. That is about gameplay, so not menu stuff. Let's move it around a bit. This is going to take just a second. Okay, so now we have two separate packages on the top level. On platformer, we have gameplay and menu, so we can easily check what's going on. Second thing I want to do is move this splash series component into the rendering package, and also introduce a splash package here and move those two inside. Okay, let's make sure everything is working. Let's make sure that everything is still working. Okay, so we are seeing that the splash screen is still working. So I haven't broken anything. Let's first of all reduce these times so I don't have to wait for 6 seconds before application starts. This can be later on changed to fit whatever you want, add new images and so on and so forth, what you want to do. So I'll add a new event here. Let's call it splash screen ended. It's going to extend an event. And the system will send this event after all the splash series is finished. So whenever we remove the background image component, it will just send, we're over with the splash screen displaying. So now let's create here a new system. So what we want to do is, after displaying the splash screen, we want to actually show the main game menu to allow creating a new game. This is the most important thing here. So I've already added two UI elements here for buttons. We'll be using this as a 9-patch images, which basically means that this is a description of how some kind of field will be filled out with pixels. So in this case, this 9-patch image basically will specify that there's going to be an imaginary line here after a 5th pixel, 1, 2, 3, 4, 5, and the same in a vertical manner, 1, 2, 3, 4, 5. We'll have a horizontal imaginary line here, which basically means that we'll be drawing this corner. I don't know if I can select here. Okay, first 5 by 5 images in the upper left corner, the last 5 by 5 pixels in upper right corner, the last 5 pictures in this corner on the lower right side and lower left side here, and everything in between. So all the pixels between the left corner and bottom and up left corner will be filled out by stretching this 1 pixel height element here. The same on the right side, top side and bottom side, and the middle pixel in this case will be filling out the rest of the image. So this is the 9th patch. If you want, you can read a bit more about this. This is very useful and very common technique in 3D graphics, especially around UI rendering. And we'll be using this to draw buttons to start a game. So let's go with creating a new class here. Let's call it a main menu system. We have to register system here. And we have to make sure that the profile this is going to be used only in profiles, in menu, not in gameplay. So in here we'll have to load some stuff. So we'll have to inject Atlas texture Atlas registry to be able to register some textures, and texture Atlas provider to be able to get the textures from the registry. So first of all, we'll describe that we want to load these two images. So button as it is now, and button when someone hovers over it. So we'll specify here string UI images. UI/button PNG. As you can see, UI/button PNG, and the same for button over PNG, and texture Atlas registry, register texture. We'll specify that texture Atlas ID is UI, and here is the images we have to register. And now we will receive event. Splash series finished, and we want to listen on the splash screen ended event. So in here we will be first of all creating. So I've created a class which is called Stage UI System, which we activate by using Stage UI profile. That's what we have to add to menu context. And this exposes a interface in a context which is called, what is this? Just called Stage Provider. Stage is a class that is in libgdx, which is used for rendering UR elements in very easy fashion. So I provide a link in the description to show you some kind of stuff you can do with UI in libgdx, and I'll just come with creating a text button. And we have to pass a text. Let's call it new game. And text button style is probably the easiest way at the moment to define how the button has to look. So style requires us to specify a 9 patch. It's one of the things we can pass to style to specify the upstate. So upstate. So this is this class defines how this button is rendered, and buttons have a couple of states, which is like up, which is like default look of the button, and another one we want to specify is over. So whenever a mouse is over the button, you can also specify a couple of different ones, like up. There is checked, because this is for checkboxes, checked over, down, and so on. So down is whenever someone button is being pressed, but will not be overriding those. So in here I have to specify drawable. And one of the possible drawable is 9 patch drawable, to which we have to specify the patch. So we'll have a button up, to which we have to pass a texture region. So we'll go to texture Atlas provider, get texture UI, UI/button PNG, and we'll have a 9 patch button over, get texture UI button over PNG. So in here we'll press button up. So I'll just, rather than create it here, I'll just pass it directly here, and button over. Awesome. Another thing we have to specify to a style, to a text button style specifically, is the font that is being used. And for this we have to use bitmap font. Bitmap font is a very, it's basically an image containing all the characters in the font that are being loaded into the graphics card, and then every character is just rendered at a specific place on the screen. However, creating those is very difficult. However, there is a tool that allows you to generate the bitmap font class based on a TTF file. TTF file is a standard font file that you can find download for free on the internet, wherever you want. And to generate a bitmap font out of a TTF, you will use TrueType. Let me check. I think it's called TrueType font generator. FreeType font generator. Sorry, FreeType font generator. And we have to pass a file handle to it. So it's going to be JDX files. JDX, yes, this one. Files internal and font/life is Goofy. This is one of the free fonts I found that I found interesting for displaying something. You can use whatever font you want. There's plenty of them available for free. And then whenever we want to generate a font, we have to specify the bitmap font. We have to specify the parameters for it. So we have FreeType font parameter. And in here we have to specify params. Size, let's say 40. Color, let's go for white. Params, let's go for border color. There's a couple of stuff you can look through the freedom find parameters. There's a lot of different parameters. You can have a drop shadow. You can have some spacing between characters. Size, there's a default of 16s. Whether you want the font be flipped vertically, how anti-aliasing is working basically. So a couple of awesome stuff here, but I'll just define a couple of base ones. So border width, for size of 40, I'll go with 3, and I'll specify the min filter. I think default is nearest, yeah, which is very, very bad. Texture for linear, and the same for magnifying filter. And then we'll have button font equals FreeType generator, generate font based on the parameters. And this something that you have to store, and we have to dispose of it in the post destroy button font. As I said, these button fonts basically loads an image with all the characters to the memory card, and of course at the end we have to make sure that we unload this image from the memory card. So this is one thing. Another thing we can pass here is characters, which is basically which characters. For example, if you wanted to have Japanese characters or whatever other type of characters, by default the characters are, let me find default cars here. This is unfortunately very, I think they are defined here. So by default, this is the characters that are being loaded. You can specify a couple of different ones, like Japanese characters, whatever you want, as long as the TTF supports those, because not all TTF files have all characters defined for them. So in here we'll specify that we want to use button font, and in here we'll pass this style. Then another thing that we have to do here is we use stage provider here, and stage provider of course provides us with the stage. Stage is basically the way libgdx renders UI by default. You can do your own stuff, but however they already have some UI done for you, so you can work much faster. You don't have to start from scratch with rendering all the images and so on. So we'll add actor, because you have actors on stage, and we could add directly the button here. However, then it means it's going to be rendered at the lower bottom side of the screen. We want it in the middle, so we'll use a class called table, which is something similar to HTML table, where you can, by default, it's going to be centered on the screen, and this is what we want to, exactly what we want to achieve. And we do table set fill parent, so that the table should take off the whole contents of the parent, which is in this case is a whole screen. If you pass this to the stage, and we have to add the text button to the table. So we create a table, add a text button to it, and then make the table the actor, which is saying that it's taking all the whole screen, to make sure that we get the button nice in the center. So another thing we have to do is to communicate with the UI. So we have to pass events to it. Mouse and buttons events, you all have to consume them. The way we can do it here is, I think the easiest way to do it is just to use a class called input event queue. We're going to create this in here, and we'll connect it to libgdx. The method is called set input processor. So this is basically accumulates all events from mouse, touchpad, buttons, keyboard, whatever else, accumulates them into this queue, and then we'll be draining this queue to whichever context is currently active. So if the menu context is active, we'll drain the events, pass the events into the menu context, is the gameplay, and we pass the gameplay context. So we specify that all the inputs from all the different devices that we have should be passed to this queue. And then in here, if we are showing menu, we'll be saying menu context, get system, UI processor, process UI, and we pass the event queue. I have to fix this. This is something I haven't fixed yet. Okay. So this is, you don't have to worry about this. This is something that is coming with the gaming module, and you don't have to worry about that. Okay, so now we create the button. Whenever the splash screen series has ended showing up, we are creating a button for new game, and we are adding it to stage, and we are passing all the events to this button from here. So let's check that it works. I know what's not going to work. I didn't specify the 9 patch correctly. Let me just fix this after we show that indeed it's not working correctly. Okay, you see this is all stretched. I have to specify here in the 9 patch the where the imaginary lines lay on here. So it's going to be 5 pixels from the left, 5 pixels from the right, 5 pixels from the bottom, and 5 pixels from the top. This is the values that I'm passing there, the 5, 5, 5, 5. If your 9-patch images larger regions for this, you have to pass different values, and based on this, it's going to be displayed. But let's see how this works. Okay, we have a button that is, when I hover over it, changes the image. At the moment, pressing it doesn't do anything. We are using this font here with border, white color, black border. Everything is working fine. Okay, so let's now try adding the button should do something when we are actually pressing it. So add listener, you click listener, and we have to override a clicked method. Let's for now new game clicked. This is what we're gonna do, just display a text in the console. Check if it works. Okay, we are seeing this happening here. Okay, so now I have a class that allows me to call a new game. So now what we have to do is somehow communicate between the context of the menu context to the gameplay context. I'll create a new interface here for doing just that. Is let's call it game state. And it will have one method specifying should show many. And we'll be passing gameplay context to it. So our menu context will have this class in it, the system implementing this interface. So we'll have here class game state switcher. Register system, profiles many, shared game state class. And this class will, okay, we'll have here an event, new game requested. And the main menu system in here. We don't really have an entity at the moment to call this on, so we'll just, for the time being, use the rendering entity. New game requested. So when this button is clicked, this event will be passed, and the switcher will be listening on this event. And it will and the method it should implement is called should show menu. It's gonna be default true, and if this is called, we'll switch it to false. And instead of in a platformer doing this stuff, loading levels and so on, we'll do this in game state switcher. We have gameplay context, create player, and we'll load just one level here. There's no need for loading everything. So we'll create a player in the gameplay context and load the level. This one, and we'll return that. So this should be done only if should show menu true. Maybe not this way. And level player created, level loaded. So this is basically this whole state. If it's true, then we have to make sure that if not player created, we have to create the player. If level is not loaded, we have to load the level. Okay, so that's what's gonna happen here. And rather than having this variable here, we'll call if menu context get system game state should show menu passing a gameplay context. Then we do menu stuff, otherwise we do this stuff. One more thing I have to change. I didn't this last time. This is incorrect. We have to notify all rendering engines that we are resizing the screen. Otherwise, whenever we switch between the context to use them, they will not know about the screen sizes. Okay, let me run this and see if it works. So now, after clicking my new game button, I should be switching to a game context in a very crude way, but I'll work a bit more on it later. So we have button, and we are switching to new game. Awesome. So what is left is going back from this when I die, going back to the main menu, which is something I'll probably do in the next episode. Okay, that's it for this episode. Make sure to like it and subscribe to my channel. Thanks for watching. Bye.